Can everyone hear me? So I'm really excited. I've got 30 years of telecom, so I'm an old telecom guy, both from a VoIP and a wireless perspective. So welcome. This is a beautiful demo room. This is a joint collaboration between ADLINK and Intel. We're all very, very excited. And what we're seeing here on the two displays is in the joint demo room, and the key purpose of the joint demo room is to have all these devices interact with one another. We have 40 gig switching, we have media server devices, we have rugged devices, we have industry devices, and they're all connected together. The operators have to deal with, you have wireless, RAN technologies, Wi-Fi technologies, Ethernet, optical. Data center space, it's pretty much just Ethernet. In the telco world, you have NEBs. These things have to stay up 7 days a week, 365 days a year, 6/9 carrier grade capabilities. Redundancies, those type of things that are going to make the virtualization happen in the long run. So industrial cloud computing is really moving that private type infrastructure into a public type infrastructure for the operators. NFV. So if you think about the operator's problem statement, as Sandra was saying, you have network elements like crazy. You have MME from Ericsson. You could have an Alcatel-Lucent serving gateway. You have a Cisco box that's doing all the routing capabilities. You'll have a firewall protection from FortiGate. You have all these different network elements on so many different platforms, and it's becoming unmanageable. It's becoming costly. The hardware redundancies that's going on, over provisioning, all these things are happening. So with the network function virtualization, we want to start moving this infrastructure into a virtualized environment where you would have possibly the entire EPC, the Evolved Packet Core, onto an Intel core, basically a virtualized core system. In the RAN environment, in the radio access environment, you'll have BTSs and the radio networks all becoming into a cloud environment as well, managing different antennas that are out there. And in a virtualized environment, you no longer have to go out and buy this big, massive box. It's now software defined. It's now virtualized in this cloud environment. With different blades doing different things. You can have NPU blades doing network management. You can have control blades handling the control plane. You can have processor blades handling the server aspects of the link. So all this is in an aggregated environment, twofold. So working at Nortel for 28 years, you could fill this entire floor up as a carrier office with switching gear and so forth. Now we're moving into a modular intersection point where you're now taking modular compute platforms, pooling them in an environment that makes sense for a virtualized telco space. And as we look into the future, we're getting into more pooling of the attributes of our system, pooling compute, storage, memory, and booting sequences all in both the data center space and a carrier space. And in this environment, if you look all around us, there's a lot of gear, it's humming, it's got fans going on, there's lights flashing on and off, and basically what we're showing here is the rugged server is over there. We've got a switch-based system here, a 40 gig switch. And a software-defined server, we have a virtual EPC, Evolved Packet Core, that's running in a virtualized state, and a media cloud server, which is over here. We have a gateway function, which is over here. We're using OpenFlow with a switch, which is, I believe, right here on a 40 gig switch, with an SDN controller. And on the edge communications, which is our rugged servers, which we're introducing today, is you would put this into a very harsh environment to handle a lot of the RAN attributes, which could be in this example, a stadium, an office building, a house, and you have one controller managing all of those antennas. Great example. So before, you have these closed platforms that are an access network. These are your antennas that you'll see in the distances. And in that antenna, you have network efficiency with that one antenna. You have a BNC and RNC. All these different network elements are built into that. Well, now with this rugged server, we can put all those network elements in a controlled status and manage multiple antennas throughout that region. So you're now moving that cloud environment from the core back to the edge. And what we'll be seeing in the future is technologies in which these antennas will become more and more smart for handovers, both to each antenna and also into the Wi-Fi space. HXC 1000, very rugged box. It can go to minus 40 C up to 55 C. So lots of different environments that are not in control. This could be outside, it could be for rail systems, it could be for telco systems, it could be in homes, it could be in shopping centers, where EPCs are now getting more involved at the edge. And also, you know, we're looking at the military aspects as well, so we could look at military connectors to even make it more rugged. Waterproof, dust-proof enclosures. No climate control is really needed, so it saves cost, cost of ownership, cost of power, cost of cooling. We have crypto engines on board for security purposes, and we have field-accessible dual SATA trays in the front. Also, ADLINK has a program called the Packet Manager, and part of that packet management system is a thing called DPI. You've probably all heard DPI in the industry. That's deep packet inspection, and deep packet inspection is becoming more and more important, mainly because of the control aspects of your data plane that's going across. Things like inspection of the content going in and how I manage my traffic. How I differentiate all that content and managing the traffic based on the content going forward. How I can monitor it, doing analytics based on my network. How do I adjust my network? How do I do load balancing with the network? And then of course security, IDS, IPS protection, firewall protection, all uses a deep packet inspection. So we need those tools, we need those capabilities to do DPI, both at any rugged server, a normal server, whether it's a 14U or a 2U. As I said, we have this application-ready intelligent platform. This is our packet manager. We have, as the telecom industry is moving forward, we're seeing a total separation of your control plane and data plane traffic. And with that, on the primarily focuses on the data planes. How do we manage that data plane? So over here, you're actually seeing some of the real-time attributes of this Intel demo room, where we're seeing the bandwidth. We're running our intranet through here. So you're seeing our cache server, our throughput, the types of traffic that's being done, the protocols that we're seeing, and of course the caching attributes from of what we're doing. So we're running about 15% hit rate on our vCache. And all that's being done really because of the ADLINK packet manager and some of the DPI functions that we're using. So we're managing the CPU, we're managing the memory, we're managing the power consumption, and we're managing all of those packets that are going through our internet through this demo room today. So that's it for the demonstrations. Please walk around, please talk to our guys here while you're in here. Look at the equipment, and thank you very much. This is very exciting.